210.
Hello! Hello, hello! Hello, hello. Welcome to the stream. Hello, welcome. Hello. Welcome to the stream. My name is Brenden. This is Doge. My name's Doge. She's a Doge. She's hanging out, barking. You wanna go on the chair? Wanna go on the chair, do spinsies? She's pretty good at this. Pretty good at spinsies. Good girl. Okay, she hates that. Okay, let's put you over here. Let's put you over here in your spot. There you go. Good girl. Hello, my name is Brenden. Welcome to the stream. We're talking about Rust programming. This series is called Cracking the Coding Interview with Rust. We're going through this book here. It's a book called Cracking the Coding Interview. It's about interviewing. Contains 189 programming questions. We're going through the questions. We're solving them. We're solving them using Rust. Rust is a hip new programming language. It's pretty cool. So that's what we're doing. Welcome to the stream. Thanks for coming back. If you are a return viewer, or if you're returning, if you are a fresh, brand new viewer, then thanks for tuning in. Thanks for joining us. It's very exciting. Very excited to be here. It's a beautiful day here in New York City. Feels like summer today, or at least the beginning of summer. It's warm, but it's not obnoxiously warm yet. So that's nice. Gonna remove some of the puppy fur from me, so I maybe look a little less like a bit less like a homeless person. I was homeless once for a while. Wasn't so bad. Not in my case. I imagine it's pretty bad for some people though. All right. Look at that. Hardly any fur on me. There's lots of fur on this. Right, pup? Little fur ball? Little puppy fur ball? Doge was recently queen of the Shiba subreddit. She was I think first and third place on the Shiba subreddit for about a day. Pretty proud of her for getting famous and stuff. It's pretty cool. All right, so to kick off the stream, let's start off with a little review of what's been going on in Rust. Let's do This Week in Rust. All right. So This Week in Rust, by the way, is a weekly blog post that's published at thisweekinrust.org. You can check it out for yourself. There's some interesting stuff this week in Rust. A lot happening in Rust core. I'm not going to go through all these. I'm just going to talk about some of the highlights. So here's one thing I saw earlier, which was a blog post about how to actually debug Rust in VS Code. And the post goes into some of the details of what's good and what's bad about debugging Rust. For example, if you're trying to get into certain structures, then you kind of reach the point where everything is just, indecipherable nonsense. Like, let's see, they have an example. Yeah, like in a hash map, you basically just get indecipherable crap. So, like, it works. It's definitely better than nothing, but some of the tooling still has, still needs some work to really work properly, right? Like, yeah, what is NatVis, by the way? I have never actually used this. Interesting. Cool. Visual Studio 2017 has NatVis for C++. It's not great. I have a lot of complaints. It's way better than Rust's nothing. Oh, I think it's referring to just with regard to hash maps specifically. But to be fair, simpler data structures, yes, like vectors or even, you know, just a string or whatever, those work pretty well. Sometimes that's all you need. Plus, in my experience, at least when it comes to debugging, at the end of the day, there's really nothing that beats print statements, to be honest. But sometimes you don't know what to print, and it can be helpful in certain situations to have a debugger. I don't think a debugger is a substitute for print statements, though. In most cases, you can't really use a debugger. Like, for example, if you are trying to deploy code somewhere and let's say the error or exception or whatever only happens occasionally, you can't really just jump in and start a debugger whenever it happens to happen, right? Yeah, so logging is important. That's the lesson there. All right, here is another cool thing. So this is an attribute to generate documentation. It's this safety attribute. This is a crate, something you can use if you want. So if you're writing a library or something and you have code that is doing something unsafe, you can use this to automatically generate safety-related documentation in a consistent way for your functions. So that's kind of cool. What else? So this is a post that I think made it to the front page of Hacker News for a while. Actually, it's about hash map implementation details, and this post is specifically about something called hash brown, which is a new implementation of a hash map that's going into Rust. I guess it's in Rust Nightly. I'm not sure when this will be in like stable Rust, but anyway, it's a new implementation and it's a little faster. And what the post was about was the fact that if you look at the code here in the insert function, you'll notice something a little odd, which is that it's basically doing two lookups on the map, right? First you do a get here, right? And then here it's calling this really insert on insert. So this post goes into why that's happening. I'll give you the TLDR, which is pretty simple, and that's that there's an SIMD or SIMD, I don't know how people pronounce that, instruction optimization. SIMD stands for single instruction, multiple data. This is like an optimization in CPUs that lets you, well, quite literally apply one instruction to multiple pieces of data. So it's a way of parallelizing operations. Anyway, I guess what happens is that this results in doing two simple SIMD operations. And anyway, if you're interested in this stuff, read through the post. It's pretty interesting. So another thing that happened is the Learn Rust with Entirely Too Many Linked Lists book got updated for Rust 2018, which is, I guess, the current, I'm not sure what you call that, standard or version of the Rust lang. And so this post was really useful for me actually when I was trying to get through chapter 2, which is about linked lists. Also, I need to check my sound. I didn't do that. Make sure. I guess the current. Yeah, my sound's working. We're good. I can hear myself. Excellent. So anyway, this has been updated. You should have a look. If you're trying to, if you haven't already, if you've tried to implement a linked list in Rust, you probably already looked at this. But anyway, it's been updated, and yeah, that's that. So check it out if you want. All right, here's something else that is cool. If you come from any other functional or functional-esque, functional-ish languages, or not even necessarily the languages, but like cases where people follow this pattern of chaining these function calls together. There's a blog post here about how to do chaining in Rust in a slightly more concise way, I suppose. So if this is something that's interesting to you, check it out. It's already possible, of course, to do chaining in Rust, and you do this by simply having a function or a trait that implements that returns whatever the struct is that you're implementing that trait for, right? Like this, where you have chain and then you return, takes in self and returns self, right? Something like that. Anyway, this post goes into a little more detail on how to apply this, how you might use it, when you might use chaining, what it looks like, so on and so forth. Yeah, even talks about this cascade crate, which provides a way to use cascade-like expressions, which is kind of like another variation on chaining. And yeah, anyway, it's pretty cool. Check it out, read it if you're interested in that stuff. There's lots of other stuff going on in Rust land. There's an interesting post that I saw on Reddit recently by, let me just find the post. One moment. Here we go. From Stephen Klabnik, who is basically just writing about some of his experiences in Rust and how essentially like the whole ecosystem has become really quite big, and so on. TJ Walker, hello. I'm not sure what you are asking about regarding Fluent Interface, but yeah, thanks for dropping by. Welcome to the stream. Hello. All right, so that's it for now. The little weekly what's happening in Rust review, not comprehensive. Fluent Interface. Still not sure what you're referring to, but yeah. All right, so what I'm doing here on the stream, the topic of this is going through this book, Cracking the Coding Interview in Rust. This book is by Gail Lockman McDowell. There she is. And going through the book, we are solving the problems. We're in chapter 7. If you want to follow along, look at the code and actually see what's going on, you can go to my GitHub profile, which is just my name, Brenden Matthews, no values. Oh, the chaining stuff, Fluent Interface. I don't think I have heard that term before, but Let's check it out right now. Yeah, okay. I see. So yeah, so you could definitely, so like one way to use chaining is to build interfaces like this, right? Get it, I get it, okay. I haven't heard this, I haven't heard it called this before, Fluent Interface, but yes. C# uses Fluent extensively in Link. That's right, Link. It's pretty ugly in C++. Yeah, you see this a lot, like in Java, for example, and other languages. Sometimes in Scala, see it a lot in Scala, and probably like Ruby as well. Python is a language that you don't see this much in. Python is really like not a great language for doing functional programming in general, for a variety of reasons. One reason being that it cares too much about white space. Is this the standard way of working in Rust? I would say that Rust encourages certain types of functional programming patterns, but so far, at least in my experience in Rust, I haven't seen a lot of examples of this like Fluent Interface style of libraries or anything. And yeah, I would agree that like to a degree this is stylistic, but presumably with things like, you know, like this Cascade crate, or I go back to This Week in Rust, or yeah, making it easier to build interfaces with like chaining. I imagine, assuming like people start doing this more, you'll probably see more and more libraries that use it. But at least in my experience, it doesn't seem to be that common yet. And if I were to guess, I'd say it's because it's a little bit hard because of how Rust works to actually implement this, I think. Maybe. I don't know, I'm just guessing. I really don't consider myself to be an expert at Rust yet. Hopefully someday. That's why I'm going through this book, doing the problems, hoping that I can learn a lot more about Rust and, you know, hopefully teach some other people something too. I hope people get value out of this. That's my goal. And yeah, so anyway, if you want to follow along, go check out the GitHub repo under my name / cracking the coding interview Rust with dashes in there. It's my name without any vowels. And let's continue. So the next problem, we're on chapter 7. The next problem is we're on chapter 7, problem 10. Problem 10 involves implementing Minesweeper. It says, design and implement a text-based Minesweeper game. Minesweeper is the classic single-player computer game where an n-by-n grid has B mines or bombs hidden across the grid. The remaining cells are either blank or have a number behind them. The numbers reflect the number of bombs in the surrounding 8 cells. The user then uncovers a cell. If it is a bomb, the player loses. If it is a number, the number is exposed. If it is a blank cell, this cell and all adjacent blank cells, up to and including the surrounding numeric cells, are exposed. The player wins when all non-bomb cells are exposed. The player can also flag certain places as potential bombs. This doesn't affect gameplay other than to block the user from accidentally clicking a cell that is thought to have a bomb. Tip for the reader: if you're not familiar with this game, please play a few rounds online first. All right, that's a good idea. So I have played this game, but it's been a long time. I don't think I've played it since like the 90s, probably. So let's see if I can find Minesweeper Online. All right, open up an incognito window. Oh, look at that, right here on Google. Medium, sure. Okay, so you can either flag or, oh boy, what happened? All right, so clearly there are bombs here. There must be a bomb here, and there must be a bomb here. Yeah. It's probably not a bomb here. Let's try that. Boom, just got lucky. All right, perfect. So this one is a 2, that means there's a bomb here, and there must be a bomb here. This is a 1. These must be bombs down here as well. So let's YOLO click right here. Oh, there we go, 3. So there must be one here. Oh, it said the 8. Yeah, I just realized it's the 8 squares around. So that includes, does that include these diagonal ones? Like, no, is that too many? No, that's right. Yeah, it's all 8. Okay, so it can be one of these like adjacent squares, or it can be on the corner. Yeah? Okay. Cool. So we're all 1, 1, 1, 1. 1, 2. Anyway, okay, I get the game. Oh, blew up. I lose. All right, whatever. I get it. Let's do it. All right, so let's jump into the code. What was the last problem here? I'm gonna go back to, here we go. This is where there was a board. So what I want to do is I want to copy a lot of this code, because the game is going to be somewhat similar to this. What is this? Othello. This is problem 8. Paste. And we just yawned. Excuse me. So I think the thing to do is to start by generating a board. Yeah? Okay. So let's do that. How big was the board here on the Google Minesweeper? Oh, I died. It's like, well, I'll do 10 by 10 by default. All right, that should be fine. Let's change the names here. Test Minesweeper. Okay, let's get rid of some things here. I'm just gonna delete most of this stuff and start with, just start with an empty board. And then width and height. Width, height. All right. And then what do you call the hidden mines or bombs? Number of in each field. Grid of undifferentiated squares. So let's just call these squares. So let's say I have a square and it's either going to be empty or a mine, right? Does it have any other possible options? No. I suppose there's one other case, which is that it's that there are mines nearby. I don't know if I need to. I think I need to make this square thing a struct. Let's say a struct here, and then we'll say square state. And this will be either a mine or empty. Okay, and then square has state. It has some state. And then let's just have, we'll just say value, and this will just be a character. All right, that's good. Makes it easy to print out. Okay. So there's a board. It has a bunch of squares. Game result, don't need that. Get rid of this. Test Minesweeper. All right, let's see if that works. Let me change this. Stash. Let me make sure my code's up to date. Yeah, okay, good stash. Hop. I didn't add this file. Here we go. Okay, yeah, we're fine. Let's do a cargo test. I should implement all of these for this enum value. Expected 2 arguments. Right. So we'll do a 10 by 10 board. 10 by 10 board. This shouldn't be piece, this should be square with state. Square state, empty, and the character and the value can just be, just initialize it to a question mark. for right now. Missing a colon. There we go. I have an S in the end of my name square. What? No. Squares, squares. Oh, yeah, right here. Okay. An extra S. Save that. Cargo test. There we go. All right. That is the most basic thing. All right, so how should this be implemented? I would like to generate a random board. So here we have a new, and I'm actually gonna go back to that blog post on chaining, and I want to start applying, I want to start using chaining. I think it'd be nice. So let's do that. Let's try and apply what we're learning here. Chaining functions without returning self. Use before consuming, yada yada. Modifying a known value, no chaining at all. Method chaining is orthogonal to return value. Method cascades. So I would say one reason why I might not want to use this cascade pattern, well, I don't want to have to include a crate to do this. That's kind of a bummer. I would like to stick to plain old Rust, but one moment. Got a message. Beep boop. I should probably just like not look at my messages, but everything's always an emergency, right? So should I use this cascade crate or should I just return self? The thing that seems like a bummer about this cascade crate is that I have to use a macro. Seems like a bummer. That and it's not really doing exactly what I want it to. Yeah. Method chaining is orthogonal to return value. That's right. All right. Let's not get hung up on that. So we have a board And then let's say, now let's have a function called place mines, and then we'll have a number of mines, like a count of mines. And this can return a mutable ref to self. That's fine. This also needs to take in self. Mutable self ref. And we just return self just like that. Cargo test. There we go. That compiles. And here I can just say let board equals blah 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 dot place mines. Let's say 8 mines or something. Yeah? Okay. New, place mines. What's next? So let me implement place mines, which is going to, it's got to do 2 things. One is that I need to randomly place the mines, and the other is that I need to mark the squares around the mines as with like the appropriate number, number of nearby mines or whatever, right? The count. Okay. Let's do it. Also, I'm going to add one more value to my I'm going to add an integer, which will be the count of nearby mines, and I'm adding this as a convenience thing so that this will speed up this will make the algorithm for I'm going to make the default character here a space, so that's like empty. Anyway, keeping track of the nearby mines like this will make the algorithm for filling the numbers much faster. You'll see why. I will only have to like it'll make it order n, where n is the count of the number of mines, as opposed to order 8n, where n is the number of squares in the board, right? So the difference is I'm changing it to be in order of number of mines instead of number of squares, which is a little bit faster. It's a tiny optimization, but you know, whatever. I'm basically trading off a little bit of memory space by storing a count of the nearby mines like this, instead of, I need to initialize that value to 0. Yeah, instead of having to compute it for each square each time. Okay. All right, let's do this. So to place the mines, I will just create a I'm just going to create a vector here and say let mines equal. I basically want I want to convert a range to a vector, so I just have a list of numbers, and then I'm just going to shuffle it and then pick the first n. Or I could choose. I guess I could just like choose randomly. But whatever, I'm going to do it this way. I also want to go back and look at one of these problems where I used shuffle and copy it. Yeah, okay. Shuffle. So mines is going to be a vector range. Can I do this? Rust range to vec. Oh, okay, cool. Take the range and then just do collect. Got it. So this will be 0 up to the squares dot length times self squares 0 length, like that. Okay, that's probably going to complain. Just a moment. I think it's going to want me to specify the type. Yes. Okay, this will be a vector of usize, probably. There we go. That's good. All right. Now we can say mines.shuffle. Restart RLS. I'm not saying cannot borrow is mutable. This needs to be mutable. Mutable mines. There we go. Cargo format. So we have shuffled mines, and then I will place the mines. So each mine represents a position in the grid somewhere, right? Like if you just imagine you number each square starting from 0, like 0, 1, 2, 3, so on. Each mine here, whatever in this, represents one grid. Okay, so I would say for location in mines .iter.take. I want to take the first count, so I only want to grab the first n, where n is this count, basically. Yeah. Let's just print this out. Print line. Location. I should basically just print some, in this case, 8 numbers. Okay, let's try that. Cargo test. No capture. Test no capture. There we go. Location 4, 33, 36, 88, so on. So those are our eight random locations. Those are the locations where our mines will be placed. So to calculate the mine location, we have to let me do X and Y. There we go. We have to break this out into its components, basically, right? So let's say the X value is going to be the number location, whoops, divided by the length of squares. Length, yeah, and then the y value is going to be the location mod by this guy length, like that. That should do it. Yeah, okay. So 99 is 9 and 9, that makes sense. 90 is 90, that makes sense. 8 is 0, 8, yep. 11 is 1, 1, yep. 42 is 4 and 2, yep. Perfect. Okay, so that maps, that is to map this location into the x and y, basically. Let's pull these out. Just say let x equal that, and then let y equal that, and we can say x, y, like that. It should be the same. Missing semicolon. There we go. All right, beautiful. Yeah, that's it. All right. So the next thing to do is to place each mine. Yeah. And I wonder if characters in Rust can be Unicode. Like if one Rust character type represents a single character. Sweet, it is Unicode, which means, woohoo, I can put an emoji in. How cool is that? All right, so that means self squares for x, y. So this square is going to, the state is going to change to, why don't I just put a new square here? Let's just make it a brand new square and say square where the state becomes square state. That's a mine. And the value is going to be a bomb emoji. Yeah. And nearby mines, I don't know. It's going to be 0 for right now. Okay. So now that I have all that, there's still more to do, but the next thing I want to do is write a function so that I can actually print out this board. Yeah. The trait std format display. It's not implemented. So let's learn how to implement this. How do I implement display? I think I have done this before, but I forgot. So gotta do it again. No big deal. All right, implement format display for my board. Let's just put in some junk here, 1, 2, or whatever. I'm doing this just to see that this compiles. It should be std, std, just like that. Let's change that to a reference. Temporary value dropped. I see. I need to go back to that blog post. This week in Rust. Temporary value dropped while borrowed. Yeah. Modifying an own value. Chain self. Make some changes to self and then return self. Well, can I just do that like this? Chemical is mutable. Chaining by returning self. It's not working. All right, this is fine. I can just do this differently. Board equal board, blah, 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 and then, okay. There we go. All right, so that prints. Now let's make it actually write out the board. So how are we gonna do that? I need to calculate the board size. So, so the board that I want to print out is going to look something like this. There'll be like a top, which will just be underscores like that. So let's just say I have a very simple 3x3 board. It's going to look something like that. And then this is one square, another square, 3. Right? That looks like a 3x3 board. Okay, so first line is going to be basically for each square, I need to print 1, 2, 3 characters, and another 1, 2, and then another 2. So it's basically the number, so it's going to be the width times 2 plus 1. Okay. Yeah, okay. Rust string join. How do I join? String list join. I don't want to. Okay, I think I can do it like this, where I say I'll basically say write f blah, and then I'll do a vector of in this case underscore, and then the number of underscores is going to be 1 plus 2 times self.squares.length. Oops. I'm going to remove this. Can I be formatted with the default formatter? What do you mean? Can I use colon question like that? No, sorry, that's not what I want. I want to take this vec and then I want to, yeah, join that. Do a join on that dot join. Double quotes, wrong. Join, no method join found for. What am I doing wrong here? Slice. Oh, is it because these are, because this is a character instead of a string? Change that to double quotes. There we go, okay. So that's the first line. And then I will say for underscore, because I don't care about the value in squares, self.squares 0. So just iterate over first there. Then I'm basically going to do this, where it's like this. This isn't going to be quite right, but just bear with me. It's going to be, yeah, like this. Number of these would just be square length, yada yada. Okay. So for blah blah blah. I need to add one more down here to print the bottom. Plus this function has to return a result. Cannot move, sorry, what? Can't move out of bar. Why is that happening? As ref? No. squares at first. Unwrap. There we go. Sweet. Okay. I need some new lines in here. Like this. And I think, sweet, that prints my board. Minus one thing, which is, I want to separate. There we go. Okay. I'm also going to make the board a little bit wider here. So I'll go one, two. And then I also got to put the character in there. There we go. So make that 4. Added 2 additional things, and then this guy. I need to print the I need to put the actual character in here, so it's slightly more tricky. Forgot about that. So let me generate the vector here for this row. So I'm gonna have to say for I, this isn't quite doing what I want. This is gonna be for each row in my board. I want to print out, my sound still working? I think so. I think we're working. Okay. For each row. Right line. Good to know. Got some green squigglies there because I'm putting a new line here, but I should just be using right line. Okay. This last statement doesn't need a new line, I don't think. All right. So I need to generate each square in the board. Add how shall I do that? I basically need to iterate over each column in every row. Pretty simple. Okay. Let's say let mutable squares equal just an empty vector of type. Just an empty string vector like that, and then for cell in row, in each row. Squares dot push, and then do format. Cell dot value. Okay. And this, I want it to be like that. Yes. Okay. And then here, I'm just gonna write out and say, squares dot join. Oops, I have the parentheses in the wrong place there. There we go. Cannot move out of borrowed context. Why? Why is that? Why is squares? This is a vector. Is it because a borrow happens? What if I just change that to a reference like that? Yeah, there we go. I don't know why that works, but it does. Okay, so that looks okay, except for one problem, which is that the emojis are a different width from the rest of the characters, but I'm okay with living with that. So sweet. I have an extra right here at the end. What should I do about that? I can probably just say right. I'll just do a right line like this. Just to make everything happy. There we go. Okay. Aside from the issue with the emoji width, character width being different from the other characters, in my terminal that looks pretty alright. Pretty alright. I think this should be 2 and an extra. I don't know, that's too much. Okay, 1. I'm just trying to make it look good. Looks sort of good. It doesn't look that good with the emojis because of them being a different width than other characters. That's probably more an issue with my font or the terminal, iTerm or whatever. And how it's rendering those, but regardless, Minesweeper's happening. Yeah. Okay, let's do one more thing. Let me address these squigglies. Unused, blah, 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 that must be used. Okay, question mark, whoops, question mark. That should make those warnings go away, shouldn't it? It doesn't like me doing this right line thing like that. These should go away. Unused that must be used. No, I'm using it. I'm using it. How do I return? I wonder if I, instead of doing it like this, I should just use format and a string like this. Okay, yeah, let result equal string new, and then I will do this. Result append format, something like that. This might not be the right way to do it in Rust, but I think this will achieve the result I want. Result append format. Mostly I just want the warnings to go away. That's what I'm trying to do. Okay, and then write f loop result. Without that semicolon. Okay, there's no append. How do I add to a string? Rust string. How do I append? Push string, push, that's to push a character. Insert, push string. There we go. Push string instead of append. And make these references. Yeah. Mutable. Beauty. Okay. Just need to add missing new lines, new line, new line, new line. Is there a format line? Useless use of format. Apparently I'm still doing it wrong. But it's printing what I expect. All right, how do I deal with my useless use of format? Oh yeah, I can see why that is useless. Oh, wait, clip errors went away? It's not useless anymore? Oh, it's, I see. So what I should do actually is just say, get rid of this format, and then do this, and then just add a new line to the end, like that. Then I don't need this format. Okay. I still need that one. I don't need this one. This needs to be a reference. This needs to be a reference. Is that better? Expected string. What does push return? Push doesn't return a string. I see. That's annoying. Alright, I'll just do the push after, like that. That's the same result. Okay. Boom. Pun intended. Okay. We got it. Cargo format. It looks okay. It's not beautiful, but it's doing what I want it to do. Even though my bombs are, my mines are messing up the thing, because they get a lot more width than other characters. Let's see if I can just, for the purpose of this, for the purpose of this here, maybe change my font or something. Text, anti-aliased. Use a different font for non-ASCII. Oh. Whoa. That's not any better. I don't understand why they're different widths. Character spacing. Let me just try changing the font for a second. No. 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 Alright. Just put back characters. Typography. Number spacing. Glyph variants. Contextual alternatives. Okay, I'm going totally on a tangent. I'm oh. Cancel. I don't know what these checkboxes mean. I'm just kind of clicking things. Alright, forget it. It's just not gonna look right. I give up. Unless, let me just try one thing. No, I'm not gonna do it. Alright, good enough. If I just change the emoji to something like, see, why does it take up 2 character widths? If I just change it to like a star like that, there we go, then it looks right. But it's not as cool as using the bomb emoji. Don't understand why it gets two character widths. Let me do a quick Google search. iTerm to emoji width. Emoji width is wrongly displayed. Huh. This is, which is narrow in Unicode 8, but wide in Unicode 9. So weird. So is it because bomb is is this one two in width? Let's try that. That's not good either. What about the dynamite one? There we go. That one displays right. Don't ask me why. I don't know, but it doesn't display it all in VS Code. Amazing. Amazing tech. Technology is the future. Here we are. Okay, so let's do a thing which, so we place the mines. The next thing to do is to mark, for each mine, mark all the adjacent mark every adjacent or every nearby square as being occupied. Okay, let's write an algorithm to do that. Let's say function mark nearby squares, and it's going to take in self x, y. That's it. Whoops, this should just be I'm writing the function signature, but what I mean to be doing is writing the call here. Okay. Self.mark nearby squares x, y, like that. All right. So this algorithm, pretty simple. Okay, so we'll do for x, and let's say for j in, and this will be from -1 to 1, inclusive range. Okay, and then for let's do I here, and then for j in -1 to 1, like that. Let's just print these. I, j, and then I'm just going to return self here. I just want this to exit early so that I can make sure this does what I expect it to be doing. Oh, yeah. These are usize, missing the type and the signature here. Usize. Missing this arrow guy, the return value, and it's not letting me do that. I'm just going to make this not return anything. Right, that's better. Unexpected token. What did I do? Self, mark nearby squares. Cargo format. Also, this should be mutable self. What did I do? 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 Mutable self, x, y, line 60. Oh, there needs to be a semicolon there. How did that happen? I'm not sure. Okay. There we go. That is doing what I want. Perfect. All right, so here I need to increment all the squares around, basically. So here I want to say so this is going to be let, I need another letter. I've already used X. I'm going to say let X offset, or no, that's a bad. Let's do this. X offset, yeah. Let, and then I'll use I equal X plus X offset. Okay. Like that, and then here we'll say Y offset. I'll say let Y equal Y plus Y offset. Like that. Okay, so if Y offset equals to 0 and X offset equals 0, skip. So basically gonna mark each square except for the square in the middle, right? So skip this guy. What do we say? Continue or next? Okay. Otherwise, is that not a thing in Rust? New size can't be negative here. So, okay. How do I do a range in Rust that starts at -1? Rust range negative. -1 as U size. I do want to do this. I realize that it doesn't like it, but I do want to do that. I want a range that starts at -1. All right, how about I just do a range from 0 to 3, 0 to 3, and then I just say Y offset -1. That'll do what I want. X plus X offset -1. This will still overflow, however. That's fine. Don't care about that. This loop never actually loops. Okay. we go. So this is a little bit ugly, but it'll do what I want. And then here, I very simply say, if I less than 0, continue. And then, or sorry, if I is less than 0 or I is greater than or equal to self squares length, continue. And then down here, do the exact same thing, except it should be j. And then if j is less than 0 or j is equal to I squares 0 length, that'll do. Very good. Very, very good. Very, very good. Very good. Okay. Let's format that. Casting I32 to I64. Well, alright, whatever. Let's just leave that to make everyone happy. I think everybody's happy. Clippy's happy. Casting I32. Let's just change this to I32. Now I'm casting U size to I32 though. Good. We'll just like this. Expected I32. Yeah, that needs to be I64. It has to be I64. Okay. Then lastly, here we say self squares I j dot nearby mines plus equal 1. Oh dear. Slice indices are of type. Okay. Gotta cast these back to U size as U size. As U size. Beauty. Okay, and then I need to actually put the character in there. Rust, integer, true character, from digit. Sweet. From digit. From digit, from digit, from digit, squares. That value equals from digit, from digit, from digit. Put that there, put this here, put this here, put that there, from digit. From digit is the one that I want. I want from digit. I think I need an STD here. Oh dear, oh dear. Found enum option. Expected type. from digit unwrap. Yeah. Expected U32 found I32 as U32. Cast it again. Sweet. Does that work? No. My algorithm is wrong here. It's kind of right, which is cool, but it's mostly wrong. Kind of right, but mostly wrong. I think maybe because it messed up something, some math. J, Y, X, Y. Okay, that's right. So if Y is 0 and X is 0, so it should be Y offset minus 1. So it'll be minus 1, 0, and then 2 minus 1 is 1. So it's J. Okay. So I and J and J and J. How bizarre. What is actually happening in my algorithm? I think that, so it's really weird. Like I've got these nearby squares here, and then what? 1, 1, 2, just way out here in the middle of nowhere. Completely messed it up. Y offset. So both of these are 0. Skip. Yeah. Yep. So this is gonna go minus 1 and then burp. So this should result in, oh, I forgot to remove this return statement. Sweet, okay. Still totally messed up, but that's okay. So then down here, I will say, add one more check and say if yada yada yada, if this is empty. So basically, I only want to change the values if it's not a mine. If this square is not a mine. Makes sense? Boom. All right. So that mostly looks right. However, it looks like there's a bug where this corner up here is not being set. That is what? Minus 1. It's like minus 1 and minus and plus 1. Minus 1 and plus 1. All right, we're pretty close. Pretty close. Pretty close. What do you think, Doge? Hello, Doge. I don't know what she thinks. I don't have a magical crystal ball into her brain. So that would be, no, that would be -1 plus 1. So it's like, yeah, okay. So that would be, so if j is less than 0, or j is greater than or equal to the length, yeah, continue. That looks right. So if these are both 0, do nothing. These are both doing 0. Skip this square. I should initialize this to 1, because it's 1 because there is one nearby mine. That is the mine itself. Might as well keep it clean. Yeah. Right, puppet, little doji, puppety, little puppety doji. Hi, little doji. Such a happy little puppety. Where are we? Where are we? Where are we? I should also feel like I should generalize this like code here for checking all the adjacent squares and just turn it into a function that takes a closure, because I'm probably going to need to use this exact same algorithm again. So let me also just do that right now. Let's call it visit adjacent squares. Okay, let me go back to some of my old code and just find something that took a function as a parameter, a higher order function, as they say. Higher order function literally just means a function that takes another function as an argument. And I'm looking for an example of that so I can copy the syntax, because I don't remember exactly what the syntax is. Why is it taking me so long to find one? I feel like I do it all the time. So the bits problems, insert, here we go. Here we go. Here it is. This is, paste that here. Okay, so visit adjacent squares, and I'm going to take a, should Should this be a mutable function? I think so, because it's probably going to operate immutably. Let's just say yes. Okay. Mutable f, like that. Yeah. See if that compiles. It does. Okay. And then let's go ahead and take the body of this function and just copy it up here. And so right here, I'm going to change this so that it calls f with the square. Squares f like that. That should be a ref. Something like that. Unexpected close delimiter. Got one too many semicolons. There we go. Okay. And then I should actually just be able to delete all this. Here, here, here. And then just say self dot visit adjacent squares x, y. And then the function is just going to be square. And then this block of code here. Okay. And then I just get rid of all this and say square. And this is going to need to be a mutable ref, like that. Mutable reference to the square. Types differ in mutability. Expected type, square. That should be fine. Oh, I see. There we go. Nope. What's wrong? Expected type. No, I think RLS is just wrong here. Okay. Square is not declared as mutable, isn't it? Isn't it? Isn't it? What if I just change that? Oh, there we go. Weird. Okay. I don't know why that was apparently removing the mutable reference, like &mute here. Fixed it. Okay, but does it even work? No, the algorithm still doesn't actually work correctly because I'm not, for some reason, the top left corner square is being skipped. Why does it get skipped? So that square is going to be -1 and +1. So let's just print out a whole bunch of stuff here. Print line. Okay. X, Y, and then I, and then J, and then X offset, Y offset, X, Y, I, J, X offset, Y offset. Let's just see what it prints out. Let's see if it makes sense. Okay, so X and Y, 2 and 6. So that's 0, 1, 2, and then 1, 2, 3, 4, 5. No, 0, 1, 2, 3, 4, 5, 6. That is this guy. So it should be visiting 1 and 5, right? Which would be 1, and I see 6 and 7, but no 5. So there's 0, 1, 0, 2, and 1, 0, 1, 1, 1, 2. I see. Y is... Oh, yeah, okay. It's because... Hold on. I'm checking the wrong value here. Okay. So this should be 1. It's because these are offset. Yeah, all right. There we go. Boom. I think that is correct. Yes. All right, cool. Let me also just copy this into main here, like that. So that it makes those green squiggly lines go away. Let me delete this print. Whoops, what did I just do? I don't know what that was. I'm gonna sneeze. Maybe. Possibly a sneeze. Okay, maybe not. No sneeze. All right, Minesweeper. Minesweeper, Minesweeper. I'm gonna boil some water. Make some more tea. Push the button on my kettle thing. It's probably a good time to take a break. I have some other chores and stuff that I need to do today. So hopefully I can finish this Minesweeper game today, at the very least. Let me take a quick look at the book. I want to have a little preview into what the next problems are. See how long they'll take. So let's see, what are the next problems? The next one, problem 11, is called File System. Explain the data structures and algorithms that you would use to design an in-memory file system. Illustrate with an example in code where possible. Okay, seems pretty straightforward. I don't know how long it'll take until I get into it, but I don't know, we'll see. What else? Hash table, design and implement a hash table which uses chaining linked lists to handle collisions. Okay, I think I could probably make a link or a hash table fairly quickly. We'll see. I should be able to finish this problem today, I hope, but it might take a little while longer. I haven't really implemented the gameplay aspect yet. At this point, all I've done is initialize a board and implement a function to print out the board. Okay. So let's take a little 5-minute break. I'll come back and continue working on this guy. Yeah. Be right back. BRB. Hello. Little snack. Eating some nuts. Got some tea. Hot tea. Right. We're making Minesweeper. Minesweeper the game. Let's do it. Let's get back in the code. Let me pop these guys on so I can hear what's happening. Music. Beep boop. This is how I dance. This is me dancing. All right, cool. So we have basic Minesweeper. Prints out all the stuff. Now, the next thing is to actually initialize the board properly. So there's another enum I need to have here. Wonder how I should do it. So by default, when you start Minesweeper, let's go play Minesweeper again. By default, when you have a Minesweeper board, okay, yeah, get rid of this thing. By default, when you've got like an empty board like this, blank, right? And you're supposed to, you can either click, well, in this case click, but you can either expose a cell like that, or you can flag one by right clicking in this case. Yeah, let me make it bigger as well. So by default, the board essentially displays as empty, right? So what I need to do is add two things. So I think state might be the wrong term here. I need like a I basically need to know if it's a mine or not a mine. So let me change this. So square state should really be let's call it basically whatever the default state is. You initialize it and let's call it unexposed. Okay. So there's unexposed, there's empty, then there's going to be flagged. Unexposed, flagged, empty, right? So every square should be unexposed by default. And let's put a question mark in to represent that. How's that gonna look? Yeah, we don't have mines. We don't. So what I'll do is I'll add, to represent whether or not it's a mine, I'll just have an is mine boolean like this. And we'll say is mine false. It's false by default. And then state, so state stays the same. The only thing that's changing here, actually, the only thing that changes here is mine becomes true. I'm also going to take this out where it skips the current mine. Okay, and then say if not square. Actually, this doesn't even matter. This matters though. If actually, none of that matters. Let me take all of that out. All I really want to do here is increment the nearby mines. Okay. There we go. That's basically the default board. You don't know what anything is. That question mark is one of these magic to width characters, so I'm just going to change it to be a regular question mark. There we go. This is our default board where essentially you don't know where any of the mines are, right? So how does playing this game actually work? Fifth binding, whose name is just one character. That's annoying. Can I just maybe change these and say, let's do X, I, and Y, J. X, I. Is that better? All right. So those are the states: unexposed, flagged, empty, flagged. Should be exposed. Okay, that's better. Unexposed, flagged, or exposed. And then I just need to add two functions here. We'll say expose square. I'll take an immutable self and then X new size, Y new size. Okay, so expose a square, and then let's say flag square, something like that. So the next thing we should do is add a function to check. So the game is won when the player wins when all non-bomb cells are exposed. So let's just add a very simple function here to say what? Let's say game result or get result or something, whatever. So we're taking self and then we'll return, let's say, a game result. And then game result is just going to be let's make game result in enum. And we'll say enum game result. It's either going to be unfinished, like you're not done with the game, lost, or won. Lost, won, right? We can copy these guys. And let's see, so basically as long as the game isn't finished, you can keep playing. Simple enough. Okay, so we'll say basically iterate over all the squares. So for row in self.squares, and then for square in row.square row. Yeah. Here I'll just say if square is mine and square state equals square state exposed. So if you expose the mine, then your game result is lost. Okay, so that's one possibility. Now the default case we'll say is game result 1. But if square.state is equal to, or rather if the square is not a mine, so else if the square is not a mine, if it's not a mine and square.state is equal square state unexposed, then this needs to be, I need like a mutable result here. Let's say result equal result equals game result unfinished. So basically, if there are any squares that are not mines and those squares are unexposed, so if you have any unexposed non-mine squares, then your game is not finished. Yeah? Okay. This should be mutable. There we go. Okay. So that compiles. And here, let's see. Let's expose a square. So what happens when we expose a square? Let's play the game really quickly again, just to see. So I already forget. Minesweeper, click to play. So click, okay. So that exposes basically all the adjacent guys that are, well, I'm not sure. What happens if I, okay, so it's all the adjacent numbered cells, I guess. Because if I click on a number, it only exposes that one number. But if I click on an empty cell, then it exposes all the adjacent empty cells, as well as any adjacent numbers. Got it. All right, let's try that. So expose square. So the first case is, let's make this return a game result. So if this square, x, y, well, let's just mark it as exposed first. Let's say self squares x, y state equals square state exposed. Boom. That guy's exposed. All right, if this is a mine, then return game result, you lose, right? Here, just return result. Okay. So expose the square. Great. The next case is if, else if, so if that square has no nearby mines, then we'll say self expose neighbors. We'll call it XY. Okay. I have to implement that function. It doesn't actually exist yet. We'll copy the signature of this guy up here. And I'll implement that shortly. Okay, so expose neighbors is a little tricky because you need to essentially find all the neighbors that are find all neighbors that are unexposed and what? Well, let's jump into it. Okay. So self visit adjacent squares x, y. So what do we need to do? We need to look at every adjacent square. And basically, if it's not a mine, if not self, or if not square is mine. Okay, so if the adjacent square is not a mine, then expose it. Square state equals square state exposed. So that guy becomes exposed. The next case is same as this. Basically, this becomes recursive. So if this square has no nearby mines, then also expose its neighbors. Right? You know what? This should also give an X and a Y in here. Okay, so this should take in this should call, yeah, this function should also have usize, view size like that. So like that. Excuse me. Unclose delimiter. What am I doing here? Oh, I'm missing a semicolon. There we go. Can't borrow self twice. Can I pass self into this? Like that. Closure requires access to self, but it is already borrowed. You can put the closure in its own scope. I see. I don't know if this is quite applicable. Solution is to make the first borrow end before the second one occurs. It's also possible Okay, can I not just pass this in? Hmm. I'm not sure what the best way to fix this is. I get it. Self is borrowed twice. What if I got an idea. Let's do this. Let other neighbors equal. I want a vector of usize a tuple. Like that. It's kind of a weird workaround, but I think it'll work. Okay, other neighbors, push xi, yj. Should be mutable. All right, that works. A bit of a clunky workaround, but it'll do the trick. Okay, so then I just do other neighbors dot iter dot for each, and then xi y j. Oops, that's the wrong function. Just 1 second. This should be self dot suppose neighbors. There we go. Sweet. It's kind of a janky workaround for that. I feel like the compiler should make an exception, but I may be missing something. Whatever. Okay. That works. So expose squares, expose neighbor. Let's just try playing. See what happens. Place mines. Board. Say expose square, let's say 3, 4. And then print the board. Okay. I need to add one more thing, which is I need to change the square y. The display value. Let me do this. Let me say self.set display value on some square. X, Y. Okay, that's better. And then just add this function. Should set display value. And this should take in a mutable square. Okay, and then mutable square, square. And then match square. Is mine. Case true. Okay, so if that's a mine, make it dynamite. Okay, if it is not, do another match, square dot nearby mines. How do rust matches work again? Rust match. I think I have the syntax wrong. Oh yeah, okay, there's no case. Right. Okay. So if there are 0 nearby mines, then square dot value. I can also just change this to say square dot value equals match blah blah blah. And then here I just return empty. Otherwise, return std character from digit square dot never minds base 10. Yeah. I should make this actually a trait on the square here. Okay. Impl square. Mutable self. 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 Okay. Let's just move that up here. Expected character just needs an unwrap, and this needs to be cast as U32. Beauty. All right, looks like my first attempt at playing, I died. Oh, there we go, got a 1. Overflowed its stack. So what's happening here? Exposed neighbors. So the square is not a mine. Expose it. And if the square has okay, so I need to skip I need to skip the self square. So if xi is equal to x, and so if these are the same, skip y is equal to yj. Skip this square. There we go. Okay. I want to get a case where it, no. Okay. Didn't fix that. Skip this square. And then this should just be else if. Presumably I am blowing up the stack in here. But I don't know for sure. See if I can get a stack trace out of it. Rust overflow stack. How to diagnose stack overflow issues? It doesn't unwind and is not catchable. You need the compiler to insert stack probes. No, that's not working. Alright, let's see if I can just debug this without dealing with that. I'm pretty sure the issue is in this code. I'm like somewhere between 20 and 80% sure that this is where I'm overflowing the stack. So let me check this algorithm. Basically, I expose the square, and then I'll say, and then here it says, so if this square is not a mine and it has no nearby mines, and I'll expose all nearby neighbors. Okay, and then exposing nearby neighbors involves simply visiting every adjacent square. And so skip the current square, yeah. And then if this square is not a mine, make it exposed, and I should just add a function. Oh, you know what? I should just call expose square, right? Yeah, this code's redundant, so I should actually just say expose these. Expose these, push. All right, so if that's not mine, expose these, and then this should just be expose square, like that. I think that is how do I ignore the result? Return value of this. I don't really care. I just have to wrap it like that. There we go. Okay. Still overflowing the stack. That's okay. I think I understand why now. Let's just add a print in here. Yes, I know why now. I'm passing the wrong values. It's going to, basically the problem is that it's trying to revisit the same squares over and over and over. Yeah, makes sense. So there's a couple ways that I can fix this. Let me think. I think probably what I need to do is pass a set through and then skip everything that's in that set, basically. Yeah. What else could I do? Actually, there's probably one more thing I can do is just say if the square is not a mine and square.state is not equal to There we go. I think this will fix it actually in a slightly simpler way. There we go. Okay. Sweet. That works. All right, so implemented expose square. Let's do flag square. Flag square is a lot like expose square, but slightly simpler. So I can only flag a square if it's not exposed. All right. So that square has to be unexposed and then set it to flagged. That's basically it. Right? And so set display value will change a little bit. We'll say match self.state. Okay, and if the state is exposed, do this. If the state is flagged, return, is there a flag? Yeah, sweet. I think that's a double width emoji, but whatever, let it go. And then if the square state is unexposed, question mark. That's it. That's basically it. There's really nothing else to the game. Let's see what Clippy says. Let me copy the code here into main first of all. Cargo format, Clippy. You seem to be matching on a Boolean expression. It's true, I am. I guess Clippy doesn't like that. Okay, let's not match on a Boolean expression. So if if do this, else Hello, Gaff from Blade Runner. Yes, I did make Conky. I'm responsible for that. Welcome to the stream. 48. Flag square is unused. Yeah. Do you use Conky? Are you a user of Conky? Let's flag a square. Let's flag 0, 1. Let's put that above here. And also down here. There we go. Oh, that's cool. Well, I'm glad that you got some value out of it at some point. Let's see. Sweet, that works. I flagged a thing. Oh, it died. Died. Let's see. Let me add the result here. Let's say result equal that, and then print line game results is result. Game result unfinished, lost. Sweet. Unfinished. Unfinished. All right, that's it. That's it. I think we're done. Did it. Let's check that in. We're finished chapter 7, problem 10. All right, I just pushed that up to GitHub. Let's see, let's take a look at the next problem. And I'm gonna think about whether or not I wanna jump into it. All right, so we just finished Minesweeper. It's problem 10, chapter 7, problem 10, right there. The next problem is file system. Explain the data structures and algorithms that you would use to design an in-memory file system. Illustrate an example in code where possible. Sure. So in the Unix world, a file system is essentially a graph. And in the Unix world, file systems are usually represented by inodes. An inode is just a structure, contains a bunch of pointers and some attributes. For example, your file might have a size and number of bytes. If it's on the disk somewhere, then it's going to be pointing to the inode or whatever is going to point to bytes, a location on the disk in terms of bytes. So basically you have a location or a pointer, you have a size. You might have a bunch of other attributes or properties, like for example, the file may have some mode set, so like read, write, execute. What else? It's going to have an owner. It's going to belong to a group. Those are the main things. All right, let's do that. This is pretty straightforward, I think. Let's go ahead and implement a file system dealy type deal. So a file system is also essentially a graph. graph is maybe not the right term, but you have every file system is a hierarchy where you have directories and files, and the only difference between a directory and a file is a file can't contain more files, really. I guess the other difference is that a directory doesn't occupy space on disk, excluding the inode itself and the metadata about the directory. So, all right, let's see. Let's make our own file system thing. I don't even know what this is really going to look like yet, but let's write something. So let's make a struct. Let's call it an inode. I hope this doesn't already exist. Probably not. It's going to have a type, and type's going to be an enum type, and it will be either a file or a directory, or it could be a link to another file, or it could be like a socket or something else. Let's just stick with these three: file, directory, or a link. A link can either refer to another file or another directory. Okay, type. So it's got a type. Let's say it has an owner. I'm just going to put a string in there. There'll just be a name. I'm not going to worry about groups or anything, but let's have some bits that we can toggle. So for example, we'll say it could be executable. That'll just be a Boolean, and then we'll have a writable bit. So writable means you can write to it. Executable means you can execute it, right? Okay, and then if it's a directory, then we will have children, let's say. And that's just going to be a vector of inode. And if the type is a link, so if this is like a symlink or whatever, symbolic link, maybe we should call it symlink. If this is a symlink, then we'll say link target, and that will just point to another inode. Right? Something like that. Okay. It's going to have a name. It's going to have a parent inode. The parent inode, this should be a reference. Can I do that? Probably not. This should probably be, can I use a ref cell? I'm probably gonna have to use some type of reference thing. Well, let's just try doing this. Let's see if that compiles. Gotta go test. No. I can't use name type like that. Let's say inode type, and then, or just do itype. Yeah, I can't. Why don't I just have a, okay, I can't do that. Can't do that, so can I use a ref cell here? Like that? this also needs to be a rough cell. Whoops. Whoops. And then use st cell rough cell. Cursive without indirection. Okay, probably need to use an RC rough cell like that. Yeah. And then use. Okay. There we go. All right, really basic inode. If I'm going to be storing the children here, these should probably be also RC rough cells like that. Do I have one too many? Yeah. Nope. Yep. Yep. Nope. Oh, my bad. One too few. There we go. All right. So there's a really basic structure, something like that. What does the problem ask? It says, explain the data structures and algorithms that you'd use to design an in-memory file system. Illustrate with an example in code. One thing that I'm missing actually is the data. Let's just say data. And how would I do this? I'll just say a vector of bytes, something like that. Okay. So if it's a file, there's some data. So that's pretty much it. And then let's make a struct file system with a root inode. That's it. Yeah? Okay, let's derive some guys here. Debug, clone, debug, clone, debug, clone. Okay. And then let's implement a couple of simple methods. Let's do, let's make a new, return self. So we'll just do a self, where the root is just going to be a new inode. I'll just say inode with name slash really the name should be empty because, yeah, the path separator is not actually a component of the name, really. Okay, so the name, parent should basically be none. This needs to be an option. And this needs to be an option. These are vectors, this can just be empty. I don't have to deal with unwrapping or whatever, that's fine. Okay, parent would be none. iType is going to be a directory. Owner, just say root. We'll say executable. True, writable, true. Children's just empty vector for the time being. Link target is none. Data toString, toString. I think there's an E in writable. All right, that's that. Let fs equal file system new. Okay. What kind of operations should my file system have? So most file systems have a stat function. What are the options to stat? Okay, stat takes in a path name and then it returns some stuff. Okay. Let's try to implement a simple stat. Let's also say let's do function add file. Okay, name string. And then we'll add some data here. We'll just keep it simple. Not going to go over the top here. And then function add directory name. Let's say path. Yeah, what should this look like? To create a file, the parent directory needs to exist. So, like, the normal pattern is that you would create the path first and then add the file. So, how about we just make it so that for right now, have to pass the parent like this. We'll say parent inode name data blah blah blah. Okay. This doesn't even need to take in self at all. Actually, let's add this add file to inode up here. Yeah. Simple inode function add file. Actually, I'll just add both of them. Add directory. This should return a RC ref cell inode. This should return the same. RC ref cell inode. Add file, add directory. Okay, delete these. And these, let's say, should take in a mutable self in both cases. Right? Okay. So basically I have my file system here. I want this to be mutable Real camera angles. Yeah, dude. I'm all about the camera angles. I've only got 2 cameras. I could add more. I do have several cameras. I could add more. Okay, so let's get the root and then let's say add directory. Well, I'll call it derp. And then we'll say let mutable derp equal that. So I have a new directory called derp. Let me test that. Test if that works. Okay, so here we're going to say let dir equal rc new rough cell new, and this should be, yeah, that's fine. And then this should be an inode like this, where the name is name. Well, I can just say name. Just gonna copy these. I just realized this doesn't quite do what I want. I really want to implement, can I add a trait for on RC, I wonder, and probably should be able to. This is getting too complicated. All right, I'm gonna remove the parent here just to keep this simple because it makes it too complicated. Okay, drop parent, drop parent. So creating a directory, it's got a name, owner. Just leave the owner as root, whatever, blah blah blah. And then I need to add this to the parent, push dir, and then returning this dir like that. This should take us reference like that. There should be name dot toString. All right, sweet. Let's copy this to file, which is basically the same. This is really not going to be complete. But I'm fine with that. Does not have a copy trait. What? Right. Clone. Clone. There we go. Now I should be able to do derp dot derp dot or mutable add file herp let mutable file equal. I don't think this needs to be mutable. No, it does. That's right. Herp, and then some bytes. Can I just say, can I just do a vector 0, 5. All right, beautiful. Well, there's my extremely simple file system thing. It's kind of meaningless, really, but I think it does what it's supposed to do. All right, Doge is having a little freak out. I'm gonna pause for 1 second here. Be right back.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
All right, we're back. We're back. Okay, where are we here? Let's copy this stuff into main to make Clippy happy. Clippy's having a little freak out about some unused code. Underscore there. Underscore here. Derp's not mutable? Doesn't need to be mutable? Are we all sure about that? Huh. Alright. Whatever Clippy says goes. Clippy's boss. Is never constructed. Never constructed. Well, that shouldn't be happening. Let's get rid of that symlink type. I'm not gonna make a complete implementation. This is good enough, I think, for the problem. All right, let's add that, and I think I'm gonna call it a day at this point. There's only actually one problem remaining in this chapter, in chapter 7. Git commit. So that's problem 11. Let's push that up. Did I run cargo format? I can't remember. Oh, I didn't. Fix formatting. Push that. Okay. Yeah, there's only one chapter, or one problem remaining in chapter 7. We're already almost done. The problem is design and implement a hash table. So probably be able to finish that, do that tomorrow. But I'm gonna end the stream here at this point. There's a hair on the camera. Let's get that off. And thanks for tuning in. Hope you enjoyed it. Hope you get some value out of it. Thanks for dropping by. Hope you come back next time. Join me again in the future. If you're watching the recorded versions, then hope you had a good time as well watching those. All right. Bye for now. Take care.